Christy?
Huh.
I noticed that on the homework that, well, I noticed on the packet that it wasn't a lot of find f. It was not a lot of find f of b. It was a lot of find absolute value from one bound to the one bound and then add the next bound because otherwise it'd be zero.
What?
It's like when we said find the total distance traveled, I just did absolute value up to the zero, and then the other side of the zero, absolute value, and added them, and I got the right answer.
Yeah, not every part. Like I was giving you full FRQs, so not every part would require the same. You know what I mean? Not every part is going to be the same problem. It's going to be different facets or different information that can be asked from the specific givens. So integration as net change was just involved in some way, shape, or form in each of the big problems that had separate pieces.
I didn't see it. Maybe I did it wrong, but I didn't see it at all.
Well, good thing is that we're in the book right now. So let's go ahead and talk about our book homework, and then we'll get back to the packet, which I think is what you're talking about predominantly, right?
Yeah.
Okay. So in the book homework, let's go ahead and check our evens real fast. What was our first one? 12. Boop. Oh, no. Guys, help me out. Remember your grading. If I don't see any colored pen marks, it better be all right, so there better be a check mark at the top. Sound good?
Or you doing it later.
Yeah.
And then you have to come back and grade and do some sort of colored pen mark so I can know what it is. Right?
Yep.
Okay. Why is it not going to number 12? Is that just me? There he is. Negative 23 centimeters. Is this the right one?
Yeah.
Okay. What's next?
14.
Oh, it's right there. Sorry. At A, we have 11. At B, we have 16. And at C, we have negative 8. Good? Number next one?
16.
Oh, he's right there. C is the maximum. C is where the velocity, the acceleration is the maximum. Is that good? Uh-oh, do I need to open up the book? Are we okay, guys? Okay, what's next?
22.
$93.6 kilowatt hours. Yeah? Number next one?
26.
2,108.5 gallons. 2,108.5 gallons. Number next one? Okay. Did we have any questions on the odds that are outstanding or on the evens that we checked?
Number 9.
Number 9.
No, 9. Yeah.
Okay. Anything else from the rest of you guys? Okay. You guys already found 9A though, right? Yeah. So then go ahead, we need 9A in order to get to 9B. What do you guys figure out for the velocity after 9 seconds?
63. Oh, no.
Okay. How far does it travel in those 9 seconds? Now that goes back to position, but what's the dilemma with what we've been given?
Oh,
We're given acceleration.
Oh, really? Oh.
So if we're given acceleration, we'll think how far does it travel in those 9 seconds? We want to go ahead and, for how far? Are they asking for displacement or total distance traveled? Yeah, total distance traveled, but how far? So we would love to do the integral from 0 to 9 of the absolute value of v of t dt, right? But the dilemma is, do we have v of t dt? Not yet. So how do we do it?
Integrate.
Yeah. So when we integrate, wouldn't we have v of t is equal to t plus, right? Integral of 1 is just t. Integral of 3t to the 1/2. T to the 3/2, right? And divided by 3/2, which is 2/3, 2t to the 3/2. But why was this clue so important? Does that make sense? So then we could go ahead and solve for our C by just plugging in 9 and 63. 9 to the 3/2. We could say 9 to the 1/2 cubed, which would be 3 cubed, 27, 27 and 2 is 54, 54 and 9 is 63. Oh, 63. Does C equal 0?
Hmm.
Double check me, you guys plug in the clue, but I think C equals 0.
You don't have your calculator on this.
I do actually.
Oh.
Thank you.
Wow.
Yeah.
That's a legit shot.
C equals 0? Okay. So then, from our clue, plugging in 9 actually gets you 63. So 63 equals 63. There's no additional constant.
Oh.
So then we can go ahead and just plug in chug it to our calculator. Sound good?
Sounds great.
It's okay. Don't you have to split it up though?
Not if we use our calculator. If we use by hand, we'd have to find the 0, which would be at 0 and
Maybe it's not me, that's why I did it wrong.
No,
well, we
it'd be at
factor
negative.
out, and so we'd have 1 plus 2 square root of t.
It would be somewhere at a negative with it, the 0.
So we'd minus 1, we'd divide by a 2, and we'd square both sides. Yeah.
Oh, that's what you did not know. You did all that. That's probably why.
How about you? Okay.
Yeah.
And then you got that for
Plug
your
in
v
and
of
I
t.
Plugged in wrong.
Maybe.
0. It would be 0.
Yeah,
that one. Yeah. Mm-hmm. Wait a minute. Maybe a negative.
but between 0 and 9, that'll be strictly positive. So technically, I don't think the absolute value makes a difference, right? Because between 0 and 9, t is not going to be negative, so then the entire expression is going to be positive. So switching of the sign doesn't really matter. I think you could just do 9 minus 0, which would be t squared over 2.
The answer in the back of the book is different, because what I just got here is the one that I got. It was 234.9.
So it's the exact same.
Yeah, but the back I think said like 300 or something. Do you have it?
No, the outside is
Have
missed.
Oh. 244.52.
Unless they're asking for the displacement.
Oh, does he feet?
Oh. I thought there was something funny about this.
So yours are fine with miles? Does that make sense?
No, but the miles still wouldn't make sense because it's 234.9 miles. That wouldn't be 300 something.
Wait a minute, this doesn't have a 0. So it's subtract 1, think of 1. What?
Miles per hour per second. Oh, stink. They did miles per hour per second. Oh, that's not cool.
You guys are tricking me.
Is it miles?
Miles per hour per second.
Miles, right? But then you change your hours to seconds.
So
That's
miles per
rough.
second squared?
Because miles per second squared is what you need in order to be able to go back, right?
That's so funny. These guys are
Why
so.
did they do this to us?
Because it comes
And
straight from
attention to
the
detail,
top.
yo. Another news, I got 1280 on my SAT.
Nice, good job.
Good job.
Sorry, did you,
What'd you get? 1600?
Would that fix it? I mean, that'll definitely make it smaller. I don't know why they would go to feet. That's kind of rough. Unless it's a fractional mile, and that would make more sense why you would go to feet.
Throw it out.
How many feet was it? 500 something? 300 something?
300 something.
Oh, it would be a fractional mile. So they went to feet just to clarify.
That's so weird.
Okay. Since we're still kind of working on 8-1 tonight, do you guys want to try the unit conversion and see if that helps?
Throw out the question.
Because if you measure t in seconds,
But then when you have to change the miles to feet, so then you would multiply by 5,000.
you technically wouldn't have to change the miles to feet until, like, you could get your final answer in miles and then convert
And
it.
then convert it.
So my assumption would be it's going to be a decimal mile, so it's going to be a lot smaller with a divide by 3600.
Can I just divide the 234.9? Or do
You
I
try
have to
it.
go before that?
My gut says maybe you should do before, but why don't you try it right now and see? So you can divide
Oh
it.
wait, 344.52? Is that the answer?
Sounds like the answer. Brian, what'd you? What's the back there?
What?
Nine.
Hold on, I think I'm doing. Hold on.
Yep,
let me try this again.
344.52.
Boom.
So we just need a unit conversion somewhere.
That's how we do.
All right. So at the end, you end up with
What am I doing wrong here? I integrated it.
my.
So now you have to divide by 3,600 times 5,200.
That's weird. You would be able to do it at the very end though,
I know, right?
because there's no time left in it. But I guess.
You're supposed to just convert to fee at the end.
Huh.
What?
George is done. All right. Any other ones that we're stuck on?
Last question. At the when you integrate, what do you get? Miles per hour?
Depends on what you're integrating. When you're integrating acceleration, you would get miles per hour. Hence why the 63 was fine in letter A, right?
Wait, if you're
So
Because it was per second. So it was okay for the first integral because it was per second. And so the 9 seconds fit. But when we take the next integral, all of a sudden we're going from miles per hour and trying to use second bounds, and that doesn't work.
so
So we could have used fractional hour bounds, and that would have worked in the sense of how many seconds is 9 seconds is how much of an hour. So you could have done 9/60ths
so
to have it match up.
but at the so you did it with 9 anyways, and at the end you had it in miles, and you converted it to feet.
No, technically Amanda did the divided by 3,600 to go back and account for the hours to seconds. But I would have probably done it in the bounds if you were to do it properly. I was a little surprised it worked.
So then times 5280. What? That's strange. If you do it in the back, if you do 0 to 9/60ths, and you multiply it by 5280, you get 96.2.
You multiply by 5,280 after?
Maybe it was 9/360ths.
Oh, 9,600.
9/3600 times 5280. No, that's gonna be a smaller number. Yeah, it's a way smaller number.
Would we be able to do 22 really quick?
It would be 9,600 so if it was in terms of hours.
So if we put 9/3600ths, it's a small number. And you multiply by 5280, it's a decimal. Here's the only way you can do it is Amanda's way.
Where am I going? Why are these two different ways? Oh, there we go.
If I wanted to find total distance traveled, I take the integral and I split it up into zeros and I take and do absolute value, right?
Yes.
Okay.
If you do it by hand.
So I'll use my calculator.
I said go ahead and use the calculator, but I said if you were to do it by hand, which is what Amanda did. All right, 22. All right, what's going on? The rate at which your house consumes electricity is measured in kilowatts. If your house consumes electricity at the rate of 1 kilowatt for 1 hour, you will be charged 1 kilowatt hour of electricity. Suppose the average consumption rate, all right, we have a model, where C is measured in kilowatts, T is the number of hours past midnight. Find the average daily consumption. Average consumption. Okay, hold on. So you're given consumption.
Because wouldn't it be 1 over B minus A, integral 0 to 24 of C of T?
Because time is measured in hours, right?
But But the thing is the answer doesn't have divided by 24 for some reason.
Average daily consumption. Wait, they already gave you average. Sorry, it's not just consumption, it's the average consumption. Okay, this is an accumulation function where you're not having to take something and average it yourself. They already gave you the average rate.
So they already did the divided by.
Exactly. Well, they didn't do the divided by 24 per se, but that is already considered in the function as given. I don't want to say they literally divided by 24 because it would have been a little messier than that.
Yeah.
But they've already done the average part. They just want you to go ahead and accumulate. Because, for instance, like you could plug in one time, right? Like 1 hour past midnight, what's the average rate? 2 hours. But you can't plug in all the possible times between 0 and 24. So the only way to accumulate that is to go ahead and throw it in there.
Okay, cool. I just wasn't sure why I didn't have it.
Yeah. Okay, are we good? Then, I want you guys to actually, accumulation was what I was a little afraid that we're a little bit iffy on. So I want you guys to try to go for a problem. Go ahead and turn in your notes. Don't worry about in your homework or in your side. I want you to try to go for a problem. It'll take a couple seconds. And see what you're able to do with that. Meanwhile, do I have enough?
I see how they did it, Miss D. You have to do you have to use seconds, but you convert in the actual function. Look.
Oh, so the way we originally thought. I was just trying to do it in the bounds. Because if you just do the bounds.
And brainly.
Because then it's a constant, so you can pull it out and then so you can multiply it up here. That's why it works both ways.
That's why we did it.
That's what we originally showed, right?
Yeah.
Yeah. Grab out your AP packet too and have that. Oh, I have 3 copies. Okay, I'm going to send you to the office real quick. Wait, you don't work on your packet?
I did, but it was really hard.
Okay, so you want to go over questions on it though, right?
Yeah, but I was wanting to
Crazy boy. Alright, hold on. Try to go for a problem real quick because this is going to help us on our number 45. Okay, let's get 6 copies. That's the office. Right back.
70.
Go for problem.
I realize that I'm kind of out of my correction papers. So you should. But here are last tests.
That's okay, you don't have to make it 2 corrections.
Yeah.
For the final term, that's being done with AP content and
Oh,
some
first
AC
try.
content by the end of the semester.
Oh, I got that one right. It's all I care about.
Uh-oh.
Man,
This is my bomb. Oh.
you didn't feel good about it, huh?
I really thought I bombed this one.
Just because mine looks.
It wasn't as bad as you thought.
Full work.
I didn't think you were going to give me the extra credit.
Everywhere.
You can part of it.
How much was the extra credit worth?
I don't know.
+5.
Yeah. You gave me all of
Thanks,
this.
Miss D.
Thanks, Miss D.
That's okay.
You're welcome. It was worth a multiple choice question.
That's cool.
This is the one.
You guys got new stamp sheets, right?
Yeah, there's only one.
Come on, man. That was funny.
Is it like 3 total? 800?
I put it in Jay's pies.
Oh, are those actual pies?
Yeah,
Oh.
so this
They
week
probably
and
are. I
then
kind of
next
just
week.
guesstimated.
It's okay. You were really close.
Yeah, this week is the last week of November.
It was just
And then
fine.
next week.
After,
Yeah. Yeah, it was kind of like there was an
I
index.
just.
When I first tried to do it without a calculator.
Yeah. I did this one without a calculator and.
Wait, guys! Go for a problem.
Pocket gophers.
Pocket gophers?
That like they can fit in your pocket?
Golfer. It's a golfer.
A golfer?
I don't know. It's a golfer.
What's a golfer? Talk about like you're from Minnesota.
Everything, yeah.
Everything.
All of it?
I just don't understand how to do it or where to start.
A 10-mile stretch of rural Minnesota road is bounded on the north by colonies of pocket gophers. Along the road, the density of gopher population is 500 per square mile. The density increases linearly until Ooh. Until it reaches 2,000 per square mile, 3 miles from the road.
What?
So,
It's X. Y equals X.
let's just say it's straight. We have our road, right?
Yeah.
It starts, and then where are you extending?
That way?
Out, right?
Oh.
Okay. Until 3 miles from the road. Find the total population of gophers in this stretch of land that's 10 miles long and 3 miles wide. So the total stretch of land, now this is not going to be the scale, obviously, but obviously, thank you. 10 miles long and 3 miles wide. That's this, and that's this, right? Aww. I'll just work for the 10 on top. There we go. Okay.
Hey, what is my house? A box on the side of the road.
So it starts along the road. Along the road, the density of the gopher population is 500 per square mile, but the density increases linearly until it reaches 2,000 per square mile, 3 miles from the road.
So from 0 to 3, it would be 2,000x.
From 0 to 3? But doesn't it start at 500 and then it increases to 2,000?
Okay, so that would be 2.
Now, linearly means constantly, right?
Yeah.
Has to increase at a constant rate. So what rate would get in 3 miles 500 to 2,000?
Well, you'd have to do
That's
2,000 equals ax plus 500
No, 2,000 minus 5. Really?
kx.
But isn't it linear?
It is linear.
Can't we
Kx.
just do rise over run? Or is that too simple?
Wait, why did you
Yeah, that's
multiply it?
ultimately what I was thinking.
Why did you multiply it?
So we could do 2,000 minus 500 over.
Because
0.
one quantity is going to be
Over
directly
minus
proportional
0.
to the other quantity. Right?
I was thinking 2,000 equals kx plus 500. Oh wait.
No, well, I guess maybe why not? Because that's the initial y-intercept.
Yeah.
Oh,
we still want to
KT.
find the. But we still.
Sorry, you mean KT, right?
But we still want to find the.
Yeah.
We still want to find k, which is the rise over run.
That's true. It only needs to increase 1,500. Not 2,000.
Wait, no, we can make t 3, right?
Because we're doing it in 3 miles.
So 3k plus 500, and then, but when t equals 3, it's 2,000, right? So we have
So,
and it's just
so it's going to be an increase of
divided by
500, right?
Yeah, and then divide by 3, so k equals 500.
Yeah.
500k.
So we can say that our density
Is a super sweet.
is equal to 500.
T? No.
I guess we could just do x, right? I guess it doesn't matter
The square
what
miles.
one we use. Plus our initial 500. So that's our function for density. And if you think about the unit of density, what's the actual unit? What's density measured in?
Mass. Oh wait, this density? Fuck.
Gophers per square mile.
Go first. You guys gotta say go first, otherwise you can't say it. It's a rule. Sorry, Joyce.
She doesn't like it?
I don't know. She might not. No, but she's not here.
So wait, hold on. Why is this a rate?
Because it's
I mean, it's not. It's technically a density, but why can we treat it like a rate?
Because the density is increasing at that rate.
Because it's something by something.
Sure.
So if you
per
integrate it,
something,
it's just gophers.
right?
go first.
Because you have how gophers are changing per square mile, and technically, how are we going to accumulate the number of gophers in this distance? Don't we want to take basically infinitesimally thin strips and figure out how many gophers are on that strip, and how many gophers are on that strip, and how many gophers
All
are
the
on that strip, and how
gophers.
many gophers are on that strip?
Wait, but if
And
we
we can't accumulate gophers unless we can make them infinitesimally thin. So we need to integrate.
wait, this T.
So density is another way, or solving for the amount, the population, etc., for a certain density equation. It's another application of integration.
If we're making infinitesimally small strips, will the gophers fit in the strips? We're gonna cut up the gophers.
We're not cutting up anything. We're not like
Theoretically,
lawn the
we're-
strips.
Theoretically, we're cutting up the gophers.
No, we're adding up gophers. Now we are technically probably thinking about gophers in fractional pieces, but that's a little
Exactly, that's it.
I know. So go ahead,
You
throw
get
in.
gopher
We need to go from, wait, what are our bounds?
0
The 0 to
Zero
1
to-
real quick.
Is it 0 to 3 or 0 to
0 to 3.
I thought it was 0
What
to
is this
1.
one?
Well, we are extending, right? We are extending out 3 miles, but hold on, does the 10 have any bearing?
Probably not.
Maybe.
No, if there's only a 10-mile stretch of road.
Why does the 10 have a bearing?
You get the
Oh,
multiplier by
because
it.
it's B, isn't it?
0 to 3 is measuring
No, I don't
miles, but isn't it in square miles?
You're
Bum,
joking.
bum,
Bam, bam,
So we don't
ba-da.
want to keep it in square miles because the 0 to 3 is only dealing in linear miles. So hold on, as we extend from 0 to 3, question, what's staying constant?
Okay.
So what are we going to do with that 10?
Multiply by it.
Yes.
Oh, then.
And if you want to think about it this way, think about your infinitesimally thin rectangular strips.
I'll go first.
Nah,
Base
they'll
times
be
height.
fine. And think base times height.
That's
So
the
what would the
same.
base be? 10. What would the height be? Well, it's the density contained in that strip. Remember, the infinitesimally thin is going to be our dx. So we can think about this as our x, and we're extending from 0 to 3. We're not just multiplying a straight 3 because the density is varying. So the dx is going to be like our little height of our rectangle. Our length is going to be the 10, and then our density within is going to be our 500. X plus 500.
I'm so confused as to how you got 500 x. You guys did it so fast.
Wait, you were doing it with us. Because you start at 500, that's the initial, that's the density at 0. And then as you extend through in 3 units, which, I mean, we're doing infinitesimally thin, but that's with the integral. In 3 miles, it needs to linearly increase from 500 to 2,000. If you just think about a graph, if that helps, if you start at 500 and if you're going to 1,000, 1,500, 2,000, if in 1, 2, 3 miles you need to go up,
Oh, I see how you did it.
does that make sense?
Mm-hmm.
So the slope's going to be, for every mile, it's going to need to increase 500.
It wasn't 3kx, it was 3k because you put 3 in the x. I got it.
All right.
Yeah.
Now
We were solving for slope, which was okay.
Mm-hmm.
So then as you integrate here, you guys just wrote in your calculators and you'll be able to solve, and we end up with,
37,500.
yeah,
That's a lot of gophers.
that's a lot of gophers. They're
Yeah,
Minnesota,
decent
though, they're happy gophers.
That's what you're saying.
Happy
That
gophers
way.
come from Minnesota. Okay, so,
Can I take some gophers home? I'm gonna
whoever has a
leave
yard is
them
going
out
to teach you
grass.
with your gophers.
These gophers love grass.
Let's see. How do they describe it? We divide the land into narrow strips, each 10 miles long and delta x miles wide. Let y be the distance from the road in the Cape strip. And they were able to make a linear equation. They went for it. Okay. Does that make sense? Let's go peek at our number 45 then. This is the one correction we weren't able to finish from yesterday. Oh, struggles is up here. Here it is. Number 45. Why does this work? Why does it apply? Because it's talking about density, right? How many bomb fragments? Come on, corrections that we're doing in.
A lot
That's like
of
gophers, except palm.
It's like gophers, but they're bomb fragments, right?
So now we can think about fries.
Exactly. Instead of gophers.
you gotta draw a circle.
Bam.
And another
Yeah.
circle inside.
Now it's circle.
Like people from Minnesota would call it BAM.
A map.
After a BAM explodes. Okay, I don't know.
We're not
Pieces can be
Minnesota
found
anymore.
scattered
We're
on them.
not.
Around the
We're
center
not.
of the blast.
We're
The
not
density
fighting the war.
of bomb fragments lying X meters from ground zero is given by, okay, so that's density, right? Fragments per square meter. I always think the units help me out a bit. Fragments per square meter. How many fragments will be found within 20 meters of the point where the bomb exploded?
A lot.
So n of x is density.
And of X is density. So we don't need to put that in an integral, but we need to make sure that we know what's going on. So hold on. Bomb explodes, we're assuming it's in a circular pattern, right?
Yeah.
And as it explodes, within 20 meters, R is equal to 20, right? But hold on, can I say that R is constantly 20, or am I going from 0 out to 20 and getting all the fragments in between?
0 out to 20.
Okay, so hold on, let's not label it with a constant 20, it's just R, and you're kind of, in a sense, traveling out, right? You're traveling out to the 20, so we're going to go ahead and throw 0 to 20. Oops, that was too bad. 0 to 20 in our integral. What does X stand for? Oh, hey, X is our
How many
radius, right?
meters?
Lying X meters away, so we can just name our radius as X. It's in terms of dx, right? Now hold on, are we doing strips that are rectangular if we're progressing out through this bomb radius?
No.
No.
We need 2
What are our
pi
strips
x.
now?
Oh, circles.
You can
2
think
pi
about them
x.
as
Like circumference or?
circles, right?
Infinitely many areas.
Infinitesimally thin circles. Now, for the rectangular pieces, we did base times height, but remember height was the dx. So in this one, ultimately, yeah, can't we just think of circumference? And then the dx is going to be the thickness. So if we have our circumference, and then we multiply by dx, that gets the thickness, and so then we have our distance.
Washers? No, not washers.
In a sense.
It was just,
But washers is 3-dimensional. So washers, you're doing area times another dimension. This one, we're just doing like surface area, so we're not doing volume. So we're just going to do the linear measurement, which is circumference, times the width of the strip, which is dx.
Oops, is it
So what's circumference?
2 pi x? 2 pi x.
2 pi. Now, why can't I fill in 20? Because it's constantly changing, right? It needs to go from 0 to 20 and go through all those little segments, all those little strips. And as it goes through all those little strips, this is going to give me miles, right? How far that little slice, how far around that slice is, and what am I going to multiply those miles by?
A lot.
Density. Remember, just like we did with the gophers.
The gophers, sorry.
The gophers.
Meters, actually.
Oh, did I say miles? I apologize.
You need something else though.
But
Because you still have per meter.
you want it.
Oh!
No, but that's perfect, because then we're
Well, how did
using
you-
the idea of an integral to undo and say, okay, let's go back to fragments.
Oh,
Now that we
right.
have fragments.
Let's go back.
I thought it was square meter for some reason.
Oh.
That's
Well, it was
wait,
square meter,
it is.
but this accounts for it, right? Because this figures out linearly the circumference of that region that we're covering with that density.
No, isn't it doesn't it give you fragments per meter now?
In the integral, I have fragments per meter squared times meters, that would be fragments per meter, and an integral undoes that to fragments, right?
Our answer is D, I think. So
Yeah, I got 7-11.
Sweet.
That's a miscount.
Yeah. B. Alright, does that make more sense? Density is tricky. I haven't seen it much, but I have seen it mostly in practice books. I've seen density problems. I have seen in a few old APs just a couple density problems. Not many, but it's still, it is an important, if you guys can imagine, if you're trying to figure out
So, like how much-
over like a certain region, yeah, exactly. How much of something is scattered is contained, how much of the population is there.
Do you use nuclear radiation?
Huh?
Do you use with radiation?
I feel like you could. You'd have to be able to mathematically model, but I feel like with experiments you'd be able to know the density, yeah, like the, I don't think it'd be called density though, technically, wouldn't it? Would it?
It's like,
It'd be called the
okay, spread.
concentration?
Maybe, yeah. Actually, yeah.
That's the idea of it. I don't know if that's
Well,
what it'd be called.
concentration I think would be like in certain parts, but like you want the accumulation of all the concentrations. So like,
Oh, like all the people affected?
yeah, like or like how much.
Yeah, you'd have to model
radiation and
like as you expand out how the concentration decreases into where it would be immeasurable or wouldn't have a measurable effect on the population. Which sadly you wouldn't want to be able to do by experimentation.
Nuketown.
Yeah. Okay, chapter 8.1, section 8.1 packet, right? You guys had questions? Let's check the rest of the multiple choice. I think did we do 1 through 4 together? 1 through 5? We did 1, we did 2,
1 through 4.
we did 1 through 4.
So 5 is.
I have 6 ready for you. 5 wasn't too bad though. What did you guys get for number 3?
What's the-
725.
Yeah, 725.
Yeah. How about number 5?
Number 5.
D.
I got D. But I felt like it was wrong because
Million
I
barrels
really had to
per
think of it.
year.
because I
Think
remember.
about density again in a sense. Million barrels per year, perfect. One integral is going to take me back to millions of barrels. Does that make sense?
But I was just confused on R prime or R. But I figured it was just R.
It's just R. I agree. It'd just be B. Because if you do B, it would stay in millions of barrels per year. D would take you back to just barrels. Does that make sense? Okay, 6. How do we do? JFK.
29.054.
That's not what I thought. I got 84.837.
Well, I got 29.054.
That's what I thought.
I did it by
I
hand.
did all of these by hand now, so that might be why.
No, I did this one I know because I did it by hand and by my calculator.
But on this one, hold on. What'd you guys put as your work?
Is it 1/8 times the integral of 6 to 14, 80 minus 10 cosine pi t over 12? Just times 6 to 14.
It'd be 1/8, but the integral is from
6 to 14, right?
Wait, what's 14 minus 6?
8.
That's what I did wrong.
But Amanda, what answer did you get?
84.837, but I might have just done the math wrong.
Oh, because that's close enough.
Mhm.
Yeah, you're checking it right now.
Yeah.
Do you guys understand average? They give you temperature, you need average temperature, so it's the 1/b minus a
Yeah.
from the integral
I
from
just
degree.
couldn't figure out the bounds.
The time interval they
Yeah.
give you is it's valid from 0 to 24, but they only want 6 to 14. Yeah, so 6 is A and 14 is B. For those of you guys that are still stuck on ones, I think almost all the rest are calculator problems. So if you're doing stuff by hand, stop.
Comforting.
What's B?
B. 5.230 to 18.769.
I got the 5.230, but I didn't get the second one.
Yes,
I don't know
I got.
why.
Wait, I got 5.231.
But it's
Because you
not
need to
like
figure
0
out
minus
when
it.
you need to figure out when your temperature is above, and so literally you're just graphing
graph
your
it.
original function. Yeah, your window should be from 0 to 24. You should be able to see the curve, and then you're graphing 78 just finding your
That's what I
second.
get for doing all of these questions.
Our admiration.
I did 5.231 plus 2 pi n for 0 to 24. That's it.
But it's not plus 2 pi n because it doesn't continue forever. It's at a certain interval.
Yeah, because it would be 0 to 24. And you don't want plus.
Yeah.
You don't want plus 2 pi n because the period isn't 2 pi.
That's what I was afraid. It's pi, right?
You have to take your 1 over or your pi over 12.
Oh.
So it'd be 12 over pi times 2 pi is every 24.
I don't know. So you're supposed to graph this?
Because you can graph your 78 and you can graph your temperature, and you're just trying to figure out for what times will it be above. And then for letter C, you have to use that, right? Because letter C says, okay, so for that time interval from 5.230 to 18.769, it's going to be cooling the house. And it says that the cost of cooling is 5 cents per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. Well, Steve, how are you going to figure out how many degrees? Well, wait a minute, what does this measure? Degrees Fahrenheit, right? So then if you want to go ahead and accumulate those degrees Fahrenheit, oh, that's not going to work. If you want to accumulate those degrees Fahrenheit, then you can say, okay, if I take all of the temperatures that are there between my 2 times, so you're going to take each infinitesimally thin strip and say, okay, what's the temperature at that time? Subtract 78, those are how many degrees above it is. The dt gives us the hours, so it's a change in time, and then my 5 cents is hours times degrees. Ultimately it ends up, now he put all this fancy language as to what was going on. But ultimately you can just take the accumulation of degrees that you get by doing the current temperature minus 78 and multiply it by 5 cents. And this one is a little bit different. It seems like density. It's kind of like density. We're accumulating, in a sense, all the degrees above 78 that it is at all those different times, which we couldn't possibly do by hand. You do it like every minute and approximate, or by every second and approximate, but that would be ridiculous if you can imagine the back and forth that is. Okay, what other ones do you guys get stuck on though? Sorry, I just camped out on 6 because I figured that was a tricky one. 7D, a model predicts the number of people in the park is a maximum. How'd you guys figure out how to find the number of people in the park?
I subtracted them.
Yeah, the
From
integral of E minus L, right? So you'd have to maximize what they called H in the problem up above. So you have to do H prime.
I got t equals 15.795, so around 3:30 p.m.
Because you're trying to find the time. You would have found H prime, Amanda said it equal to 0 to find the critical numbers. Test with 9 and 23, which are the endpoints. Plugging into H. Does that make sense?
H prime T
Equals 0. Solve for the critical number, and then you're going to make a table with 9, the critical number 23, and just test each of their H values. Who's the highest? Does that make sense?
15.795 sound about right?
I think so. Let me have corrections on the way out. Let's spend. The nice thing is we did actually technically have a couple days extra next week. Tomorrow, let me get like the full answer key for the AP packet up, and then we'll just work through it. Does that sound good? You're going to grade your own with a colored pen, and then we'll just kind of see our weaknesses and then type it. Is that alright?
Can we spend like some time on the simulation functions?
Jan did it today, not
Tyler. Hi, George.
Now, you just hand it to me, I'll pick it with them.
Hey, George.
Tyler.
Where's your brother? He's at school.
Yeah.